What's happening in our skies right now has gone far beyond simple curiosity. It's becoming one of the most unsettling mysteries in modern astronomy. Harvard astrophysicist Avi Loeb has gone on record suggesting that what we're seeing might represent nuclear-powered technology from beyond our world. Something intelligent. Something built. The arrival when telescopes first detected 3I ATLAS emerging from the frozen dark between stars, it seemed ordinary enough. Our third interstellar comet, following Oumuamua and Borisov. Astronomers logged it, studied its orbit, and moved on. But that was before the data started to break every rule we thought we understood. What began as a faint speck in the sky is now expanding into a cosmic phenomenon so vast that it could one day rival the largest structures in our solar system. Its coma, the glowing halo of dust and gas around its core, has been growing faster and larger than anything ever recorded. If current measurements hold true, it could one day rival the diameter of the Sun itself. No comet in history has behaved like this. The impossible behavior normally, when comets approach the Sun, solar heat vaporizes their frozen ices, producing the bright tails that sweep across the night sky. It's predictable. It's simple. But 3I Atlas isn't following that script. Instead of a gentle brightening, it erupted, expanding exponentially, like an explosion in slow motion. Within weeks, the surrounding gas cloud had swelled to hundreds of thousands of miles across, large enough to swallow Jupiter whole. Telescopes around the world scrambled to observe it. Hubble turned its gaze, and what it captured stunned everyone. Jets of material were bursting chaotically in all directions. The nucleus, the solid heart, was nowhere to be seen. And yet, despite the violence, it refused to break apart. The indestructible comet by all laws of physics, 3I ATLAS should have ripped itself to pieces. The same kind of explosive pressure has shattered comets before. In 2020, another, Atlas, comet disintegrated completely under far milder stress. But not this one. 3I ATLAS endured. It survived its own outbursts, holding together like it was built from something stronger than rock or ice. That realization hit astronomers like a shockwave. If this object wasn't a loose pile of rubble, then what was it made of? Metal? Something engineered? Theories spread rapidly, and the search for answers fell to the James Webb Space Telescope. The spectral shock Webb's infrared instruments began scanning its light, breaking it apart to reveal its chemistry. The results were unsettling. Yes, it contained carbon dioxide, but hardly any water, the main ingredient of every known comet. Instead, Webb detected heavy elements and complex organics, the kind you'd expect in industrial compounds, not pristine cosmic ice. And then came the discovery that changed everything. The forward light Hubble's extended exposure revealed something that shouldn't exist, a beam of light, thin, focused, and pointing forward, along the comet's path. Comet tails always point away from the Sun. That's a law of physics. But this was the opposite, a headlight cutting through the darkness. It wasn't a random outgassing jet. The light was coherent, stable, unwavering, more like a laser beam than natural reflection. Independent observatories confirmed it. It was real. Avi Loeb didn't hesitate. He said what others were too afraid to. No natural process can produce a coherent forward beam like this. The energy, the focus, the persistence, all point to one thing. Technology. Could it be a navigation light? A communication laser? A propulsion system beyond our understanding? Whatever it was, 3I ATLAS was acting like it. Now comes the most haunting part of the story. The part that feels less like astronomy, and more like destiny. 3I ATLAS The object that has defied physics, resisted solar storms, and moved with impossible precision, is now approaching its perihelion. That's the moment it swings closest to the Sun, the ultimate test for any celestial body. Here, the Sun's radiation, magnetic pressure, and gravity become a crucible. Comets melt. Asteroids fracture. Even metal spacecraft have to shield themselves to survive the inferno. But this is also the moment scientists have been waiting for, the moment when 3I-ATLAS would finally reveal what it's truly made of. Would it flare up like an icy comet? Would it fragment under stress? Or would it do something no one could predict? And then came the twist. When the most crucial moment arrived, we won't see it happen. The vanishing at perihelion, 3I-ATLAS passes directly behind the Sun, disappearing into its blinding glare. It's an event astronomers call superior conjunction, a brief alignment when the Sun blocks our view completely. Even the most advanced telescopes, Hubble, James Webb, and ALMA, are powerless. Solar radiation overwhelms their sensors, rendering the entire region invisible. For several weeks, 3I-ATLAS will be beyond our reach. No radar echoes. No light curves. No data. Just silence. To the human eye, it will simply vanish, a visitor swallowed by the very star that defines our existence. A cosmic curtain drawn shut over the final act. But hidden behind that curtain, anything could happen. The hidden maneuver to most astronomers, this timing is just a coincidence, a natural alignment in orbital mechanics. But to a few, it's something that feels calculated. Because behind the Sun isn't just an empty hiding place. It's the perfect location for something else, a gravitational slingshot maneuver. This is a real technique, used by every interplanetary spacecraft humanity has ever launched. Voyager, Galileo, Cassini, all used planetary gravity to accelerate or redirect their trajectories. By dipping close to a massive body, a probe can steal a fraction of its orbital energy, changing its path without using fuel. It's celestial judo, bending gravity to your advantage. And the Sun, of course, is the most powerful source of gravity in the solar system. A perfect engine for anyone, or anything, that knows how to use it. So the question lingers in scientific circles. What if 3I-ATLAS isn't just drifting? What if it's navigating? The theories multiply. Some theorists suggest that if 3I-ATLAS performs even a subtle course change while hidden, it could indicate controlled motion, a deliberate maneuver to slow down or enter a long solar orbit. Others argue that even a small velocity change might allow it to rendezvous with something, or leave behind a probe. A few engineers from private aerospace circles have even gone further. They've modeled how a light sail, a large, reflective surface, could use solar gravity and radiation pressure together to brake and change direction. If 3I-ATLAS's surface has those properties, its behavior could match the profile of a controlled interstellar craft. But again, these are only theories, and theories can't replace evidence. To prove anything, we need to track it. And right now, that's impossible. The waiting sky. As the weeks pass, observatories across the world stand ready. Teams from NASA, ESA, and the European Southern Observatory are preparing their post-conjunction observation campaigns. They've mapped out the exact coordinates where 3I-ATLAS should reappear, assuming it follows a natural path. But there's an unspoken tension in those calculations. If the comet doesn't reappear where it's supposed to, it means something happened behind the Sun. Something we couldn't see. Something we weren't supposed to. For now, the data stream is empty. The Sun's glare dominates every wavelength. All humanity can do is wait for the re-emergence, the moment when 3I-ATLAS steps back into view, and we learn whether it survived, or transformed. The final question: when it comes back into view, we may finally have our answer. Will 3I ATLAS emerge as a shattered relic, a comet undone by solar fire? Or will it reappear unbroken, steady, and silent, continuing a journey that no natural object should survive? For now, we can only watch, wait, and wonder. Because if what's moving through our solar system right now isn't natural, then perhaps the first contact humanity has ever experienced didn't come with a signal or a landing, but with a shadow quietly passing behind our star. Whatever happens next, one truth has already become clear: 3I ATLAS has changed how we look at the sky. It's reminded us that the unknown isn't always far away. Sometimes, it drifts right through our solar system,